In this lesson, we'll be tackling an issue of paramount importance, which is rendering animations with moving objects in V-Ray. If you have ever rendered any sort of object animations in V-Ray, you know that having a flicker-free animation is really hard to achieve and really time-consuming. Usually, if you don't consider the right steps to render your animation, your final result will be an absolute mess and you would notice flickering all over the place in your render. In this lesson, we learned the right approach for rendering animations with moving objects in V-Ray using IrradianceMap and Lightcache. We're going to be working with this scene, and if I hit play, we have this animation going on. I intend to work with just a chunk of this animation from frame 120 to 200, but if you want, you can experience with the first part of the animation too. So let me open up the time configuration window and change the start time to 120 and press OK. Let's open up our render setting. In the Common tab, make sure time output is set to single for now. And in the GI tab, set the IrradianceMap as primary engine and Lightcache as secondary engine. And let me use medium as the IrradianceMap preset. Also in the Render Elements tab, let's add global illumination and lighting passes. Without changing anything else, let's render the scene and see what we have. As you can see in the render named 01, we have visible splotches, and the first step to get flicker-free animation is to make sure that you have almost perfect GI solution on your individual frame. So if your individual frames are having a very good GI solution, your chances of getting flicker-free animations are much higher. But if the individual frames suck, there is no chance you have a presentable final animation. Also, if I go to the GI pass here, you can see the problem a bit better. Our GI solution is not acceptable at the time being. Now, in the lighting pass, we have some visible noise, but we'll be utilizing Virid Denoiser to clear these high frequency noises later on. Back to our render settings and GI tab. The easiest way to get safe, perfect, and flicker-free animation is to use Brute Force at least as your primary engine. If we set Brute Force as our primary engine and secondary engine, and then increase the subdivision to get the noise level to a minimum, and then render your scene, there would be nothing else to change. You define where you want to save your final image and render the scene. To speed up the render in this situation, you can change the secondary engine to Lightcache and increase the Lightcache settings a bit. Using Brute Force will give you a perfect flicker-free animation. The problem, as you know, would be the rendering time. If I render my scene with Brute Force as my primary engine and Lightcache as my secondary engine and render my scene, the result would be render 02. This render took 13 minutes, which is 10 times more than our previous render, which was just 3 minutes. But absolutely no splotches whatsoever. We might need to increase our Brute Force subdivision to decrease the overall noise, but generally you are guaranteed to get a flicker-free animation if you render all the frames using Brute Force. Now, in this case, we intend to render about 80 frames from 120 to 200. 30 minutes per frame is almost 2,400 minutes or 40 hours. That's a lot. For most of us, that's not a viable option. So in the render settings, let's set the IrradianceMap as the primary engine and Lightcache as the secondary engine. Now what we need to do is to crank up our GI settings until we get a clear GI solution. And when dealing with the animation, you need to really go the extra mile and make sure it is as good as it can get within a reasonable time frame, obviously. For this particular scene, I'm going to change the IrradianceMap preset to high animation and set the IrradianceMap subdivs to 90 and interpolation samples to 25. Obviously, I just didn't use these numbers from nowhere. I've experienced the scene, I have worked with the scene, I've tried different numbers, and I realized that 90 and 25 would possibly give me a very good result. So you need to go through the steps as we discussed in the irradiance map lesson, for example. In the light cache rollout, set the subdiffs to something like 1200 or even more, and retrace threshold to 8. As I have discussed these parameters in details, I won't be explaining them again here. If you have any problem understanding these parameters, please refer back to the previous lessons. Now, if I render the scene with the current settings, the result would be image 03, and if I compare it to our first render, you can see the quality has improved significantly, and the render time is only 5 minutes and 30 seconds. I mean, it really depends on your taste and what you consider good and acceptable. In this case, I would imagine an untrained eyes can't see any splotches in the scene. Now, me and you, we are working with this stuff. We know what is splotch and what is flickering, so we might be able to still find some splotches here and there, but someone who hasn't been dealing with this stuff, I imagine, cannot find any splotches or any problem with the scene. Now, obviously, you are seeing this through the recording, and the make sure to check out the history in the frame buffer on your own, because this video will go through some compressing to be able to kind of make it downloadable. You really need to check the original files in your history folder of the scene. Now, the next step would be to save out the GI solution for all the frames. To do that, change the irradiance map mode to animation prepass. Now, V-Ray asks you, where do you want to save the GI solution for all the frames? Let's go to the render output folder of this lesson. Let's create a new folder and name it irradiance map, and go inside it and set the file name to box or whatever you want and press save. Also, if in your scene, in addition to object animation, you also have a camera animation, please enable use camera path option both in the irradiance map and light cache. In the common tab, change the time output to range, and even though we are only rendering our animation from frame 120 to 200, but I'm gonna set the range from 118 to 202. So basically we are having a 2-frame margin on each side, and the reason being is the interpolation frame number in our irradiance map settings. Because imagine if we render frame 120, because the interpolation frame is set to 2, we would need the irradiance map for 2 frames before 120 and 2 frames after it, and the same thing for frame 200. So that's why we start from frame 118 and end it at 202, even though the final render will be from 120 to 200. Also, in the render elements, let's delete all the elements that we have. It's not necessary because in the animation prepass mode, V-Ray won't render the final image and only GI will be calculated, but I tend to make sure I have no render elements in this step. Now you can press the render button, and V-Ray calculates the irradiance map and light cache for all the frames in the animation and creates one separate map for each frame. After the GI is calculated for each frame, V-Ray will start GI calculation for the next frame and skips rendering the final image. As you will see, after the first frame is finished, we start calculating the GI solution for the next frame immediately. Now, We wait, and after the GI calculation is finished for all the frames, I'll be back. Now, if I open up the Irradiance map folder that we just saved our Irradiance map to, you can see we have generated an Irradiance map for each frame. The interesting thing is these maps also contain the light cache solution, so we don't have to calculate our light cache separately. In the GI tab, what we can do now is to set our secondary engine to none because all the light cache samples are saved in our Irradiance map. In the Irradiance map rollout, change the mode to animation rendering. Now you need to select the first Irradiance map in the sequence and press open. For each frame, V-Ray will use the proper Irradiance map. So if we render frame 142, the map for this frame will be loaded. In the Common tab, let's change the time output to active segment. In the Render Elements tab, let's add denoiser, lighting, and global illumination. Also, let's set the denoiser preset to mild. Now you are ready to start your final render. If you get back to the Irradiance map rollout, now that we have set the mode to animation rendering, interpolation frames parameter becomes available. And by default it's set to 2. I'll be getting back to this parameter and show you how disregarding it might lead to severe flickering in your final render, but 2 is normally good enough to give us a flicker-free render. There are several ways to save out the final image. You can use save file up here, but I usually tend to use frame buffer rollout under V-Ray tab to save out my final render. We will be discussing all of these parameters later on, but for now let's enable V-Ray raw image file. Click on this browse button here. Let's go to the final render folder in the render output folder for this lesson. Set the OpenEXR as the output format and change the file name to box and click save and start the render. As you can see, we skip Irradiance map and light cache calculation because we already have those information and start the rendering of the final image. Now you might think you are going to get faster render time per frame because you skip Irradiance map and light cache calculation. Because we are rendering an animation and interpolation frame is set to 2 and we are blending between 5 frames at each frame, the render time is not going to decrease that much, and based on the material that you have in the scene, it might actually increase, and it might increase significantly, sometimes to 4 to 5 times per frame before setting the mode to animation rendering compared to the when the mode was set to single frame. So if, for example, the mode set to single frame and you would get a render time of maybe 5 minutes per frame, if you have very complex materials in the scene, when you set the mode to animation rendering and interpolation frame is set, for example, 2, you might get to 20 minutes per frame or something like that. So you might increase your render time significantly based on your scene. Now in this case, it doesn't change that much because I don't have any complex materials in the scene. Now you just have to wait, and when the render is finished, I'll be back to take a look at the final results. Here we are inside After Effects to take a look at the final render. Let's double click in the project panel, select the first EXR file, make sure OpenEXR sequence is enabled and click import. Now let me create a new composition based on this sequence. Change the project to a 16-bit project and the working space to sRGB and enable linearize working space. And press OK. Now we are in the right color space. Also, let's right click on the footage. From interpret footage, select main, set the alpha to ignore and press OK. Now you can press 0 on your keyboard and wait a few seconds for the preview to be ready. So here is our perfect flicker-free animation, and as you can see, the result is amazing. I mean, we still have some small noise to get rid of that can be solved simply by using Vary Denoiser Pass. We already have Vary Denoiser Pass saved in our final render. So let me stop the playback here. From Effects and Presets panel, let's search for Extractor and apply it to the render. Click on this empty space and from Layers, select Vary Denoiser. Now let's press 0 again and wait for the new preview. So here is our noise-free, flicker-free render. And if this bending that you see on the wall is from After Effects preview and not from the render itself. And if you render out the sequence to a video format, you won't see that problem anymore. Now back to 3ds Max, let me open up the RAM player and open up the sequence here. Make sure the frame rate is set to 24. If you play the render, you can see we have a beautiful flicker-free render and there is no bending on the walls. Okay, perfect. Now let me close the RAM player and discuss one last thing before wrapping up the lesson. Now what I want to discuss here is the effect of interpolation frames while you unflickering. In the frame buffer, I have 3 sets of renders. In each set, interpolation frames was set to 0, 1, and 2. I have just rendered this very small portion of the image around the main sphere to speed up the process. In the first set, the interpolation frame was set to 0, and I have rendered frames 188, 189, and 190 in order. Let me go through these renders. You notice how the reflection on the sphere here is not constant throughout those 3 frames, and we get very obvious flickering even in these 3 frames. Now imagine how it would look like in the entire animation. In the next set, interpolation frames was set to 1, and as I go through these renders, you can see the flickering is a lot less. And in the final set, interpolation frames was set to 2, and as you can see, flickering is completely gone. These renders are obviously taken after we have calculated the irradiance map and GI and have set the irradiance map mode to animation rendering. That's where the interpolation frames comes to play. In fact, let me just load an entire render with interpolation frames set to 0, and you will notice severe flickering that it causes. Let me open up the RAM player. I have another folder called with reflections, and in this render the spheres are having a reflective glossy material and interpolation frame was set to 0. Let me load them in the player here. Now I want you to focus on the reflections on this big sphere. As you can see, it's severely flickering, and I can also go frame by frame so you can notice the flickering even better. So the moral here is to make sure your interpolation frame number is high enough to prevent any flickering. Okay, so that's about rendering flicker-free animations in V-Ray. I know it seems very complicated and doing this step and doing that step, but in fact, it's not like that at all. After a while, it becomes your second nature. You just watch these lessons a few times if you find the content to be a bit difficult, but I promise you it's not difficult. Just watch it again and you can see how easy it is and how quick it can be done, because I'm kind of talking about this stuff and make sure you understand everything. That's why it takes so much to set up. In fact, it takes 30 seconds to set up everything, besides the renders, but it's going to be very fast and very easy. Just try to watch the lessons a few times if you have any problem. So perfect. See you in the next lesson.